This class we are going to discuss telescopes. Okay, telescopes. Okay, what they are used for? To see the distant objects. I want to see stars. I want to see moon. I want to see peak of mountain which is very far away. We use telescopes. Okay, there are of dozens of types of telescopes. Okay, dozens of types. Okay, here we are going to look at the most basic type. Okay, the most basic. Okay, type of telescope. It is like this. Let's write few things about it. Okay, it uses two convex lenses. Lenses are used. Okay, they are called. Okay, like microscope, here also we are going to use. You see, microscope also is of hundreds of types. You can design simplest to the most complex microscope. The same way you can design the simplest telescope to the most complex telescopes. Okay, we are going to do the simplest one. Okay, the most basic type that you yourself can make. Okay, in your home you can do this. You just require two convex lenses. That's it. They are called objective. Focal length is FO and eyepiece. Focal length is FE. Okay, FO is more than FE. FO is more than FE. Okay, understood? It is the most basic type. If you try to recollect the condition in microscope, okay, in the microscope the condition was different. In the microscope it was just reverse of this. The FO was less than FE. Okay, it's like this. Let's see how it works. I have one lens. This is my lens here. Okay, this is known as objective. Okay. It is kept towards the object. I want to see moon. I will keep this lens directed towards the moon. Okay, which is essentially at infinity for lens. Okay, where will be the image? This is objective focal length. When the object is at infinity, image will be at focus. If I have extended object like moon, any star, any object, okay, extended, the image is going to be in focal plane. Okay, so this is my light rays coming from infinity, very large distance. Okay, that's how the light rays arrive. They are parallel like this. Okay, and after refraction they meet here. Okay, now this point here, this point is focus of objective. The image is always going to be at the focus. If I had directed my telescope towards a distant object, like stars, or very far off objects, in that case, this is my focal plane. The image is going to be here always. Okay, now I have one other lens. Okay, this distance here is always going to be fixed. What is going to be this distance? This is FO here. This distance is always going to be FO. Always, in all the cases. Okay, this distance I can adjust. I can move this lens backward and forward. Now, depending on this distance, I am going to get final image. Now, again, you know, if I want to see that final image clearly, the final image should be either at the near point or it should be at infinity. Okay, accordingly, we are going to get two types of adjustments: near point adjustment and normal adjustment. This point is always going to be focus of the objective. Now this distance is UE, let's say. It is distance from the eyepiece. This is my eyepiece. Its focal length is FE. Now depending on this distance, I am going to get my image at different distances. Okay, I always adjust my lens such that I get a virtual image. Okay. In that case, I am going to see my image somewhere here. If I extend it, I am going to get this enlarged image. Okay, what is this? This is the height of image, the intermediate image, which acts like an object for my eyepiece. Here is my final image. This is something that you have to remember. The final image is inverted. The final image is virtual and inverted with respect to the original object, wherever it is. Now, how do we define magnification? That's it. This is the simple design of microscope, and that's it. We are ready to do problems. No formulas. Again, no formulas. Okay? But we need the basic definition of magnification. In case of telescope, magnification is defined in a different way. Different than what we did in microscope. Again, a new thing. So we will have to make some effort to remember that. It's a new thing here. Okay? Magnification is equal to angle subtended by final image. Okay. This is somewhat simpler than the definition for microscope. Okay, over angle subtended by object. I am looking at object. Let's say I am looking at moon. I am looking at moon with my naked eye. The moon is going to subtend some angle. Okay, it is this angle here. This is angle subtended by the object on my eyes. Okay, understand this. Moon is millions of kilometers away. Not million, but whatever. 300,000 kilometers away from here. Okay. If I look at the moon from this point here, or few steps ahead of this, few steps back of this, okay, the angle is going to be essentially same. So whatever is the angle here, whatever is the angle that object makes here on the objective, on the eyes also it is going to make same angle, exactly same angle. The object is very, very far away. Few meters of difference is essentially no difference at all. Okay. This is theta O. Now this is the final image. This is the intermediate image here. Now the image made by, the angle made by this intermediate image here, this angle here, this is the angle made by image, both image, this as well as this, it is going to be same. Okay. For this lens, this is the object. So whatever angle the object makes, the image also makes the same angle at my eye here. Okay, so this angle. Now this angle made by object here will be same as this angle. It is going to be same as this angle, theta O. Okay? Understand it? So this magnification is going to be equal to theta I, angle made by object, image, over angle made by object. It's like we define magnification, height of image and height of object. The same thing here. Angle made by image over angle made by object. This ratio is known as magnification. Okay. Now, this lens can be adjusted to get my image at the required distance. It should be more than D. it can be anywhere between D and infinity. This distance here from my eyes, from the objective, from the eyepiece, it should be more than or equal to D, 25 centimeter. If the final image is at D, 25 centimeter, it is going to be near point adjustment. If the final image here is at infinity, it is going to be what? Normal adjustment. Similarly here, like microscope, the distance between these two lenses, okay, will be equal to, it will be equal to length of telescope. Length of telescope. Okay, that's it. Now, that's it. How we can solve it? So what will be magnification? Magnification is going to be equal to theta I over theta O. Okay. Let me write it here itself. Here itself. Let me write it. Okay. Or let me write it here. Let me write it here. Magnification is equal to theta I over theta O. What is theta I? It is equal to H over UE. This distance, theta I, and this is theta O here. So H over FO, this is fixed. H over FO. Okay, it is FO over UE. This is magnification. Okay, it is the magnitude. It is the magnitude. What will be sign of this? It will be negative. Okay, it will be negative. This is an inverted image. The final image is inverted with respect to the object. Okay. Okay, makes sense? Now, what about length? Length of telescope. It's very simple. L is equal to FO plus UE. That's it. That's it, very simple. Okay. Now, in normal adjustment, okay, what will be magnification? This is something that we can find very easily. Now, what should be this distance? Such that the final image is at infinity. Okay, it should be equal to focal length. Okay. In normal adjustment, UE will be equal to FE. So what will be magnification? It is equal to FO over FE. Okay. And that's why FO should be more than FE. Okay, to get magnification. Otherwise the object will be reduced in size. Okay, now then length. What will be length? It is equal to FO plus FE. In normal magnification, in normal adjustment. In near point adjustment, I will have to find this UE. I need to calculate it. Okay, depending on focal length. Okay, we can calculate it. Let's do some problems. Let's do a few problems and then we conclude it. Okay, it's a very simple topic. I hope that all of this is clear. Okay, are you able to see clearly? Yes, I hope. Okay. Now, focal length of lenses used in a telescope are 5 centimeter and 50 centimeter. Okay. Find magnification in normal adjustment, magnification in near point adjustment, length in normal adjustment, and length in near point adjustment. Okay. All right. Okay. First question. Second question. If telescope is focused on an object 2.5 meter away then what is its length in normal adjustment? Interesting, okay. Generally we use telescope to look at distant objects like stars, mountains, moon and all that. But of course, if you have a telescope, you can point it anywhere, okay. So you are pointing it, focusing it on a very nearby object, like an object which is 2.5 meter away, okay. Generally, this is not the purpose of a telescope, but of course we can do that, okay. So in that case, what will be length? If I want to see that object in normal adjustment, what will be length? Okay. Let's do these two problems. Okay. Let's do this first. Note down the problem, solve it. It's pretty much easy. Okay. This is the magnification. Okay. So first case, m in any case, theta I over theta O, it turns out to be equal to, we have this formula FO over UE. Okay. Now, in normal adjustment, UE should be equal to FE. Okay. Now, these two lenses are given, but it is not given which one is objective and which one is eyepiece. Okay. So that is something that you will have to remember. Okay. In case of a telescope, if I want to use this system as a telescope, in that case, focal length of this objective, it should be more than FE. Okay, that means this is FE and this is FO. Okay, that is something that you will have to make out on your own. Okay, even if it is not given, we can do that. Okay, so this becomes FE and this becomes FO. We have this answer. Okay, so M infinity. Normal adjustment FO over FE, it becomes 10. Now let's understand it. What is the meaning of 10? Magnification is 10 from a telescope. What does it mean? What it means is, suppose that you are looking at moon from your naked eye and the moon subtends some angle, let's say 2 degrees on your eyes, 2 degrees. Then if you use this telescope in normal adjustment, then the angle made by image will become 10 times. If the object makes 2 degrees, the image will make 20 degrees. Okay? It will make 20 degrees. Okay? So the object, when you look through a telescope, you see the object appears very near to our eyes. Okay? You can make such type of, if you have time, and if you have this passion of doing these things on your own, okay, you can actually have these two simple convex lenses from market. Try making a telescope on your own. Okay, you will see that when you look at any object from the telescope, the object appears nearer. Okay, it appears as if the object is brought near your eyes. Okay. And that's how it appears magnified. Okay. So this is about okay. And what will be length? Length will be simply equal to FO plus FE. That's it. Okay. FO plus FE. It is equal to 55 centimeter. 55 centimeter. That's it. In normal adjustment, we can directly find the answer. Okay. Not much calculation. Now, in case of near point adjustment, then I will have to find. Okay. For near point adjustment, I will actually have to find this value here such that final image is formed at 25 centimeter. Okay. Now look at the sign convention. Okay. This is the lens object. Light rays are going towards right. Okay. So this will be sign convention for this second lens here. This is positive and this thing is negative. Okay. So for near point adjustment, okay, focal length of eyepiece is given. It is equal to 5 centimeter. Okay, V is given minus 25 centimeter. What should be U? What should be U? Okay, let's find out. So 1 over F is 1 over V minus 1 over U. Okay, now this is 1 over U, 1 over V minus 1 over F. Okay, so 1 over minus 25. I want my final image here at 25 centimeters. Okay, minus 1 over plus 5. This 5 centimeter eyepiece. Okay, so we have this thing 25 here, minus 1 minus 5. Minus 6 over 25. Minus 6 over 25. This is my 1 over U. U is going to be equal to UE. Actually, this thing here, UE, is going to be minus 6 over minus 25 over 6. That's it. Okay, makes sense. Now, what is magnification? It is theta I over theta object, image over object, FO over UE, FO over UE. FO is 50 over 25 over 6. This becomes 12. 12. But generally, this thing is little confusing. Okay, when I say 12, it appears as if the final image is erect. Okay, but you have to be careful. The final image is inverted with respect to object. Okay, so actually we write it as m is equal to minus 12. This is magnitude. This is magnitude. Okay. With proper sign convention, it will be minus 12. Okay. Now the next one, the interesting one. Okay, what will be length? Length LB. It will be equal to FO. This is always going to be constant, FO plus this, plus UE. Okay, plus UE. So FO already I know 50 plus 25 over 6 centimeter. Okay, so that's it. This is our answer. Now the next one. Okay, next one is interesting. What will happen if I focus it on a nearby object? Okay, what if I focus on a nearby object? In that case, if it is focused on a nearby object, then I will get image something like this here. This will be my image. Now this will not be at focus. Okay, this distance from here to here is 2.5 meter. This focal length here is 50 centimeter. This focal length here is 5 centimeter. Okay, I want my image in normal adjustment. Normal adjustment. Okay, in that case, this should be equal to 5 centimeter. 5 centimeter. Okay, the light rays. Okay, they will make this image at infinity. This is normal adjustment. Okay, I want to find the length, so I need to find this value here. This I know, and it should not be difficult to find. Okay, what it will be? Just this 1 by f minus 1 over u, 1 over f here. I want to find this image distance. That's it. I find this value, and this I get the length. This is 2.5 meter. Okay, so 1 by v, 1 over f plus 1 over u, 1 over plus 50 plus 1 over minus 250. Okay, so this is going to be equal to 250 here. This becomes plus 5 minus 1. Okay, so I have V 250 over 4. 250 over 4. So 125. So 61.5 centimeter. What will be length? V plus FE. This should be FE 5. Okay, so we have this answer. 66.5 centimeter. Okay. Such type of simple problems are asked. Okay. Try to understand this. Understand the basic principle, working principle, how telescope work, how microscope works. That's it. And remember one basic formula. That's it. Okay. What is that? For magnification. We need to remember that separately because magnification is defined in a different way that you have to remember. And you have to know how to apply that to get the answer. Okay, let's do just one other problem and we will conclude. Okay, I think is this right? No, it should be 62.5. So 67.5. 67. Okay, 0.5 centimeter. Okay. In normal adjustment, length of a telescope is 60 centimeter and it produces magnification of 11. Okay, find first FO, FE and second MD and LD. Okay, can you find it? Normal adjustment. In normal adjustment, length of telescope is 60 centimeter and it produces magnification of 11. Okay. So you should pause the video now. Okay. Do not watch it like a movie. Do not watch it like it is not a movie. It is not entertainment. Pause the video now. Try to get some answer. Whatever comes to your mind, get it. And now here we are going to solve it. Okay. M infinity is FO over FE. Okay, that means FO over FE is 11. Okay, so FO is 11 FE. Now, length is FO plus FE. We just discussed it. Okay, so FO plus FE is equal to 60. FO is 11 FE. Okay, so 11 FE plus FE is 60. What is FE? Is 5 centimeter. And what is FO? It is 11 times 55 centimeter. Okay. Now, what will be magnification in near point adjustment and what will be length? Okay, so I want this is given 5 centimeter. 55 centimeter. This is 55 centimeter. Okay. FO is 55 centimeter. FE is 5 centimeter. I want my image here, final image here. Okay. First image is always formed here. Okay. What should be UE? Okay. So it's like this. Final image minus 25 centimeter. Focal length is plus 5 centimeter. Plus 5 centimeter. What should be UE? This I want to find. Okay, so you can find it simply using the lens formula. 1 over V minus 1 over U, 1 over F. 1 over U is 1 over V minus 1 over F. What we are doing? First image is always formed here at focus. Okay, so this distance is always going to be 55 centimeter. It is always 55 centimeter. Provided that I'm using the telescope in the way it should be used, I'm focusing it to a distant object. Okay, that is by default taken for granted that you are doing it properly. Okay, and then 55. So this lens I can adjust back and forth. Okay, I can get the image at a distance I want. Okay, so generally we adjust it either in near point adjustment or in the normal adjustment. So in near point adjustment, final image is here. This is the image distance. Focal length is 5 centimeter. This is 5 centimeter. We already got it. And then I want to find this value here. Okay. So this is equal to 1 over minus 25 minus 1 over plus 5 This is 25 here minus 1 minus 5. Okay, so I got this thing. U is 25 over 6 centimeter minus. Of course, minus makes sense here. It is to the left of this. Okay. Now, what about magnification? Let's find length. Length will be equal to FO plus UE. This is UE. So it is 55 here. Okay, 55 plus 25 over 6. That's it. 55 plus 25 over 6. Now what will be magnification? Theta I magnification in any adjustment at any distance, okay, for the final image. It is this. Okay. This is equal to H over FO. H over UE. UE. This is the angle made by the final image. H over UE here. Over H over FO. Okay. It is FO over UE. Okay. So what is magnification in this case that we are calculating? FO is given 55 over UE. This is UE 25 over 6. So 55 and 6 and 25. So 5 and 11. Okay, so this is a kind of one. Okay, so this is 66 over 5. This becomes 12.5. No, 13.2. 13.2. I hope that I did all that correctly. 13.2. What is magnification in normal adjustment? 11. Magnification in near point adjustment is always more than magnification in normal adjustment. Okay. Why that happens? Why that should happen? Why that should happen? Think about it. Why magnification in near point adjustment is always more than magnification in normal adjustment? Theta O, this is fixed. Moon makes some angle on my eyes, that is fixed. I cannot change that. Theta I, this is the angle made by final image. In normal adjustment, this value should be equal to focal length. It is focal length. Let's say that, okay, the telescope is focused in normal adjustment. That means this point here, it should be focus of the eyepiece also. This point will be focus for both lenses. Now, in normal adjustment, I am getting this virtual image. Virtual image from convex lenses. For what position of object we get virtual image? When the object is between focus and the lens and the focus. Okay, so my telescope is adjusted. It is adjusted in this adjustment, in this arrangement. This is my normal arrangement, normal adjustment. Okay. Final image is at infinity. What is length of telescope? It is FO plus this. I want my image at 25 centimeters, virtual image. My object should be between this point and this point. Okay. For that to happen, I will shift my lens towards the object a little bit. I will shift it. Length will decrease. I want this object here. To be between focus and lens. That's how I will get my final image, virtual image, at this distance 25 centimeters. Okay. The length decreases. Length in normal adjustment is more. Length in near point adjustment is less. Okay. I will have to shift this lens. Okay. Or effectively what we can do is this object is shifted. this object is shifted towards the lens effectively, okay? What will be effect on this angle? This was the angle in normal adjustment when the object was at focus. This is the angle in near point adjustment when the object is between focus and the lens. This angle increases. You see, the angle has increased, this angle has increased, and that's how the magnification increases in near point adjustment and length decreases. Okay, makes sense? Understood? Okay, so with this we conclude this lecture and this chapter also. Okay. But you see, these are the things that we forget very soon if you do not solve problems. Okay, you have to solve problems if you want this thing, because you see, I did not give you any formula. I could have given you number of formulas, but I know that is not going to help you, and it will only create confusion. Creating confusion is never the purpose. Okay. Clearing the confusion is the purpose. Okay. I'm not going to, I want to decrease your burden. I do not want to burden you with formulas, concepts, or overloading you with all those things. Your mind is left boggling, okay? that is not what is the purpose, okay? That is not the philosophy here. Okay, so next lecture, we're going to start next chapter, okay?